We are planning to do few questions from current electricity. When doing current electricity questions, first thing you should know Kirchhoff law. There are two. And other than that, actually when doing current electricity questions and electronics questions as well, you need to know how to find the potentials at certain points, point potentials, how to allocate potentials for resistors or as cells and for capacitors, all that. So in these few questions actually we are discussing how to allocate potentials for resistance and finding point potentials. Just go through with these questions first. If you can find the point potentials given, yeah, that's great, that means you are good. And if you're not, just follow through, and finally you will be able to find it and you will find a method somehow. So let's get on with it.
Alright, I hope you have tried the question now. Let's get into the question. In the given circuit, the point A is 9 volt higher than point B, right? Now you can see this cell, actually it's 6 volt cell, but the potential difference across is 9 volt. That means, yes, current is not supplied by this particular cell actually the current goes to it, so in opposite direction, right? Then the potential difference across a cell is given by V equals E minus IR equation. You should know this equation. Then again, if the current is not supplied by the cell, the equation, there's a small change. V should be equal to E plus IR, right? So we're going to apply this equation here. V is the potential difference, E is the EMF, and simple R, that's the internal resistance. You should know these equations. Then V, they are telling us, yes, we have to apply is 9 volt, and E, of course it's 6, so plus I is we don't know, and R is 1, so we are getting it I as 3, right? So it's easily 3 amperes, the total current, actually that's the total current, that's 3 amperes. Again they are asking us to find the potential difference or at these points, so we need to find the potential differences. So it's easier if we make one point grounded, so I'm going to ground here, it's 0, so the potential here 9. Then to find potential at C, we need to find the potential difference across this 15 volt cell, right? So I'm going to apply the very same equation, and I'm applying V equals E minus IR equation because current is supplied by 15 volt cell. That's supporting direction. So E minus IR. V, of course we don't know, and E is 15 minus I, of course you know, that's 3 into R. Do the calculation. R, actually it's none, it's 2, so 15 minus 6, that's 9. The potential difference is across this cell, actually it's 9. So the potential at C, it has to be minus 9 volt because the direction is C to B, B is higher, right? Again I'm going to apply this very same equation for 15 volt cell, right? V equals E minus IR. V, of course we don't know, E is 24 for the 24 cell, actually 24 minus I3 into 1, so it's 24 minus 3, of course we are getting 21 volt. That's the potential difference. So minus 9 minus 21, of course that's 30 minus 30, right? We have all the point potentials now, right? Potential difference between D and B is 30. B is 0 and minus 30, that's correct. Potential difference between C and B is 15. C, of course 9 and B 0, that's wrong. And again the other one 24, that's wrong. Can see that, and they are asking us to find the resistance R. So let's apply V equals IR for the circuit, the entire circuit. Actually it's the total E, it has to be 15, 24 plus, so it's 39 minus 6, that's 33. Total current, that's we know actually 3, and the total resistance 1, 2, 3, 4 and plus R, so 4 plus R, right. 11 equals 4 plus R, we are getting R equals 7. Yes, another correct answer. A and D is our answer. Alright students, compared with the other question we did just now, actually this question is quite easier, but still let's work on with it. So they're asking us to find the potential difference between point A and point B. So I'll ground here, so the potential here is 0, and I can find the current, or I can use potential divider method to find the potentials at A and B. So let's use potential divider method because it's quite easy, I think. So you can see this one current goes like this, right? So and 1 3 is in series, 3 1 in series, 1 plus 3 that's 4, 3 plus 1 that's 4. Then these two systems are parallel, so 1 over 4 plus 1 over 4 equals 1 over R, then R equals 2, right. Then here it's 3 ohms, here we have 2 ohms, right. So only these two resistors are there to share the potential. So 3:2 ratio, 3 over 5, 2 over 5. So we need to find the potential difference across the system, that means 2. So we need to multiply it by 10. So we are getting is 4 volt, right. Here we get 4 volt and 6 volt. Then right now we know potential difference across this system is 4 volt. Then again across 1 ohms and 3 ohms 4 volt will be shared. So again the ratio is 1:3, so 1 over 4 plus 3 over 4. So 3 ohms will be getting 3 volt and 1 ohms will be getting 1 volt. So the potential here is 0, so 3 is getting 3, that means potential at A it's 3 volt, and the potential at B, actually here again the same ratio, 3:1, 1 ohms will be getting 1 volt. So potential at B, that will be 1 volt. So they are asking us to find the potential difference between point A and B. So A is 3, B is 1, so 3 minus 1, that's 2 volt. Yeah, so that's the second answer. Alright, moving into our third question. Let's rate it. The current flowing in the circuit, okay, current is given 0.1 amperes. Okay, we have 0.1 amperes. Actually the direction should be the other way around, because 6 volt is higher than 2 volt, the current direction it's this 0.1 amperes, right. The potential difference between point X and Y, right. So the easiest thing what I can do is I'll ground this point X, and of course you can see the current flows from X to Y, so the potential at X, let's say it's Vx, potential at X is greater than Vy, of course. Then I can find the potential difference across 20 ohms. I'll apply V equals IR for 20 ohms, that's 20 into 0.1, I'm getting 2 volt. Again apply V equals IR for 5 ohms, 5 into 0.1, 0.5. So these two are in series, 2 volt plus 5 volts, 2.5. The potential at Y, it has to be 2.5. This question is quite easier. The potential difference between the point X and Y is 2.5, right.
Alright students, if you could do this question, that's great. That means you are kind of good with current electricity questions. These are not very difficult questions, but certain level, if you can do this question, that means you are up to a certain level. That's great, right? If you couldn't do these type of questions, again Yes, what I'm saying is you have to go through with your theories. Here I have given couple of questions from current electricity. So try that questions as well. And if you don't understand when I'm explaining it to you, that means you don't know anything about the theories. So you have to go back to your theories and visit your class tudes or class notes, class videos. So just do small questions and come back and do it again. So again, I'm stressing on this because if you can do current electricity questions really well, you will be getting at least 10 to 12 questions in the exam paper. So it will be really easier for you to score marks and accuracy will be really high. So take that into consideration. Try lots of questions from current electricity. You can go through with past paper questions as well, because that type of questions you will see in the paper. But still, other than that, find good questions from current electricity and keep practicing.